In this video, I'm going to show you how to solve a problem involving two analytes and two products. For example, a 6.881 gram sample containing magnesium chloride and sodium chloride was dissolved in enough water to give 500 ml solution. Analysis of the chloride content of 50.0 ml aliquot resulted in the formation of 0.5923 grams of silver chloride. The magnesium in a second 50 ml aliquot was precipitated as magnesium ammonium phosphate. Upon ignition, 0.1796 grams of magnesium pyrophosphate was found. Calculate the percentage of magnesium chloride hexahydrate and of sodium chloride in the sample. So as you can see here, we have two analytes involving magnesium chloride hexahydrate and sodium chloride. Even though in the first part of the problem, it only mentioned magnesium chloride and sodium chloride. But since we are calculating for magnesium chloride hexahydrate, sodium chloride, we might as well express the magnesium chloride in the form of magnesium chloride hexahydrate. Okay, so we need to write here, we have magnesium chloride. So we have magnesium chloride hexahydrate. We also have sodium chloride. Now, is it possible that we have other materials, other inert materials? Well, yes, because according to the problem, you have a certain sample containing these two components. So it is also possible that we have other inert materials. Okay. Now, this sample was dissolved in 500 ml solution. Therefore, we can write here, you have 6.881 grams, and it is dissolved in 500 ml solution. Now, we analyze the sample in terms of precipitating all the chloride content in the form of silver chloride. Okay, so we took 50.0 ml from this sample, analyze it for the chloride, producing silver chloride amounting to 0.5923 grams. Okay. We also took another 50 ml portion and analyzed the magnesium, precipitating it as magnesium ammonium phosphate, but the final product is magnesium pyrophosphate. Again, we are only interested in the final form, okay, which is, in this case, magnesium pyrophosphate. And the mass of magnesium pyrophosphate was found to be 0.1796 grams. Okay, so we need to determine how many equations are required to solve our unknowns. According to the problem, we have two unknowns. Therefore, we need at least two equations to solve for our two unknowns. Okay? Now, of course, it is also important here, since we don't have the corresponding formula masses, well, we might as well include that here. Okay, so let me write all the formula weights for magnesium chloride hexahydrate. Of course, you can calculate this. This is about 203.30 grams per mole. Next, you have sodium chloride, and this is 58.44 grams per mole. We also need to know the formula weight of silver chloride. And this is 143.321 grams per mole. Then finally, you have your magnesium pyrophosphate. That is 222.551 grams per mole. So this is 5. Okay. So let's go back to our problem. Okay. Now, between silver chloride and magnesium pyrophosphate, well, it will be easier to start with the weight of magnesium pyrophosphate. Why? Because the magnesium pyrophosphate will only come from magnesium chloride hexahydrate. Whereas silver chloride, well, you have two sources of chloride. You have your magnesium chloride hexahydrate and sodium chloride. So here, if you use magnesium pyrophosphate, you have a direct relationship between the pyrophosphate and the magnesium chloride. Okay, so we can start with that. Now, according to this, for every mole of magnesium pyrophosphate, well, this is equivalent to 2 moles of magnesium chloride hexahydrate. Okay, and therefore we can determine weight of magnesium chloride hexahydrate, that is equal to the weight of magnesium pyrophosphate times. Again, this is our relationship. You have 1:2. So we have here 2 moles of magnesium chloride hexahydrate. Of course, you multiply this by formula weight of your magnesium chloride hexahydrate. Okay, divided by 1 mole of magnesium pyrophosphate multiplied by its formula weight for magnesium pyrophosphate. Okay, so substituting the values, this is now equal to 0.1796 grams times, you have 2 moles times 203.30 grams per mole, okay, divided by 1 times 222.55 grams per mole. Again, we get that from our formula weights here. Okay, so this is now equal to the weight of magnesium chloride hexahydrate. That is equal to 0.3281 grams. But wait, remember, this weight of magnesium chloride hexahydrate came from only 50 ml portion of the 500 ml solution. Okay? And therefore, this weight corresponds to 50 ml aliquot. No? Which means we need to calculate the weight of magnesium chloride hexahydrate in the original solution, which is 500 ml. Okay? So this is equal to 0.3281 grams. And, well, a simple conversion from 50 to 500. So this is 500 ml divided by 50.0 ml. Okay. In other words, this should be 10 times greater than the 50 ml. Okay. Therefore, this will be equal to 3.281 grams. So finally, we can calculate percent magnesium chloride hexahydrate from your original solution. And this is equal to the weight of magnesium chloride hexahydrate. Of course, this is in 500 ml, so we will use that, divided by weight of your sample times 100. Okay? So this is equal to 3.281 grams divided by the weight of our sample. Our sample is 6.881 grams. 6.881 grams times 100. So finally, percent magnesium, magnesium chloride hexahydrate will be equal to, so I have 47.68%. Okay, so now the next question is, we need to calculate percent sodium chloride in the original sample. Okay. Now, according to the problem, well, we have here two sources of chloride. We have the magnesium chloride hexahydrate and sodium chloride. Okay, so we need to establish the proper relationship. Okay, so for one magnesium chloride hexahydrate, that is chemically equivalent, or it will produce 2 moles of silver chloride. Correct? You have 2 chlorine per formula of magnesium chloride hexahydrate. Okay? Also, you have here sodium chloride, and that is chemically equivalent to 1 mole of silver chloride. So now we need to write an equation involving silver chloride. Okay, So, according to this, the weight of silver chloride, let me write here that this is the total amount of silver chloride that is equal to the weight of silver chloride, which is chemically equivalent to magnesium chloride hexahydrate. Okay, you have a 1:2 relationship, so let me write there 2. So plus the weight of silver chloride coming from sodium chloride. Okay, so when we expand this equation, we now need to express weight of silver chloride in terms of the weight of magnesium chloride. So this is equal to weight of magnesium chloride hexahydrate times you have our gravimetric factor. Again, the solution should be equal to the weight of silver chloride. So this is 2 moles of silver chloride multiplied by its formula weight, silver chloride, divided by 1 mole of magnesium chloride hexahydrate times its formula weight, magnesium chloride hexahydrate. Okay, plus here we need to express weight of silver chloride in terms of the weight of sodium chloride. So this is equal to weight of sodium chloride times, so you have here 1 silver chloride times formula weight, silver chloride, over 1 sodium chloride times formula weight of sodium chloride. Okay. Now we know that the total weight of silver chloride is equal to, let's see here, 0.5923 grams. Okay, so that is equal to 0.5923 grams. Now, what is the weight of magnesium chloride hexahydrate? So since this solution came from 50 ml aliquot, which is the same volume used in the analysis of magnesium, so we know that the weight of magnesium chloride hexahydrate in 50 ml is equal to 0.3281 grams. Okay. So here, this is also in 50 ml, so this is equal to 0.3281 grams of magnesium chloride hexahydrate. So times, so you have 2 times formula weight of silver chloride will be 143.321 grams per mole. Again, you can check, it's right here. Okay, so divided by 1 mole times you have 203.30 grams per mole for magnesium chloride hexahydrate. So this is plus weight of sodium chloride times, you have 1 mole times 143.321 grams per mole divided by 1 mole of sodium chloride times its formula weight, which is 58.44 grams per mole. Okay, so now your unknown is weight of sodium chloride. Okay, so we can simply solve for weight of sodium chloride. And of course, you can do that using your special calculator, or you can use algebra. So, weight of sodium chloride will be equal to, let me see now, this is 0.05 to 89 grams. Okay. Now, again, since this was taken in 50 ml aliquot, we need to calculate the weight of sodium chloride in 500 ml. So this is equal to 0.05289 grams times, of course, this weight should be 10 times greater than the weight of sodium chloride in 50 ml. So this is 500 ml over 50 ml. That will be equal to 0.5289 grams. Then finally, percent sodium chloride will be equal to weight sodium chloride over weight the sample times 100. That is equal to 0.5289 grams over weight of the sample is 6.881 grams times 100, and that will give us about 7.686%. Okay, and so that's how you solve a problem involving two analytes and you have two products.